Assalamualaikum and salam sejahtera. My name is Nur Najihah binti Ahmad Zuriman, and today I'm going to present about momentum, topic 6. What is momentum? Two objects that collide have the same combined momentum before and after the collision. That means momentum is not destroyed in the collision but transferred between the two objects. Catching a baseball, the momentum from the ball is transferred into your hand, so that all forces acting on a system result in a change of momentum in the system. Talk about a few subtopics, but before we go into it, I'm going to explain to you about Newton's third law of motion. Newton's third law states that when a body exerts a force on a second body, the second body exerts an equal and opposite force on the first. Next, I'm going to talk about effects of forces exerted by fluids in motion. Firstly, moving fluids apply forces on a surfaces they touch. Secondly, caused by change in momentum, speed, or direction. Thirdly, seen in pipes, nozzles, turbines, fountains, and hydraulic machines. Fourthly, positive effect, used for propulsion, lifting, and power generation. Fifthly is negative effect. It can cause vibration, wear, or pipe damage. Sixthly, or lastly, is engineers use the momentum equation to predict and control these forces. Next is momentum equation. The momentum equation in fluid mechanics is based on Newton's second law. The rate of change of momentum of a fluid equals the sum of external forces acting on it. Components of the force. First, pressure forces. Secondly, gravity forces. Thirdly, reaction forces. And lastly is frictional forces. Meaning of the equation, any change in fluid's velocity, speed, or direction will create a force on whatever causes that change. Okay guys, so now we're going to get into momentum subtopic. So I'm going to talk about 3 subtopics. Firstly is Newton's third law in fluid flow. Secondly, application in pipe bands and elbows. And thirdly, reflection, valuing momentum knowledge in engineering practice. Newton's third law in fluid flow. This topic introduced the action-reaction principle in moving fluids, very useful for understanding how forces occur in pipe bands, jets, and turbines. It connects basic theory to real engineering application. Like example, when a water jet hits a wall, it produces a reaction force that can be measured. Elaboration. Newton's third law states that for every action, there is an equal and opposite reaction. In fluid flow, when a jet of water hits a surface or changes direction in a pipe, the fluid exerts a force on the surface, and the surface exerts an equal and opposite force back on the fluid, showing reaction of turbine. It's applied in the design of turbines. It helps engineers calculate internal loads and support requirements due to fluid motion. Secondly, I'm going to talk about water jet impact applications in engineering. In hydraulic turbines, water jets impact the turbine blades, transferring momentum and causing rotation. The higher the jet velocity, the greater the change in momentum and the greater the torque produced on the turbine shaft. Typically, jet velocities in turbines are between 20 to 60 meters per second, generating reaction forces of several kilonewtons depending on plate area and flow rate. So this is the formula. First, on a fixed plate held vertical to the jet. Secondly, on a fixed plate held inclined to the jet. Thirdly, on a moving plate held vertical to the jet. Fourthly, on a moving plate held inclined to the jet. Fourthly, on a fixed curved vane. And sixthly, on a moving curved vane. this is an example of the calculation. So the question is, a jet of water 75 millimeter in diameter issues with a velocity of 30 meter per second and impinge of a fixed plate which destroy its forward motion. Find the water jet impact force. So pi times diameter cube per 4. Then we're going to use this formula. Force equal 1000 times 4.418 times 10 times 30. So we're going to get 3976.2 Newton. Then we're going to change to kilonewton. We're going to get 3.976 kilonewton. Lastly, I'm going to talk about subtopic reflection, valuing momentum knowledge in engineering practice. So for the personnel, it's for understanding the concept of momentum has helped me realize how important physics in real engineering work. Before learning this topic, I only saw momentum as a formula, density equal mass times velocity. But now I can relate it to fluid movement, pressure changes, and force calculations in real systems. For the group, as a group, we learned that momentum is not just about motion, it connects many engineering topics. From other groups, we saw how momentum principles are used in pipe flow, pressure loss, Bernoulli's principle, and hydraulic machines. By sharing ideas, we understood that all these topics are interrelated through the same basic concept, change in motion causes force. Okay, so now it's Q&A section. So Nurina have question for me. So Nuri?
So my question is, what happened to the momentum of water that it suddenly hits a flat plate and stop flowing?
Okay, so the answer is when a water hits the flat plate and stops, its velocity becomes zero. This causes a change in momentum, and as a result, a force is exerted on the plate. The greater the velocity or mass of the water flow, the greater the force produced. So that's all from me. Thank you guys.